Alright, today's video is a standard mastery assessment solving systems of cost equations. So let's get into the first example. Here we have the question. We're just going to read through it. Over the weekend, families rushed to the theaters to see the summer blockbuster Sharks. All tickets were sold at the box office. Child tickets cost $6 each, and adult tickets cost $10 each. The total revenue collected was $1,500, and the total tickets sold was $200. And it's asking us two things. First, how many child tickets were sold. So let's focus on that for now. So we're trying to figure out how many child tickets were sold. The things that we are going to use are these steps over here. So the first step is to identify the unknowns and make them the variables. Well, the easiest way to identify the unknowns is to figure out what it's asking us for. So it's asking us for child tickets, so that's going to be one of our variables. And then, because it's talking about adult tickets, we're going to make adult tickets the second variable. And this should be number of adult tickets, number of child tickets. Okay, so step one, just make the two variables. And then step two is to create two equations based off the totals, because we're going to solve this using systems.
So we've got two totals here. We have total dollars. They collected a total of $1,500. And we have total tickets. They collected a total of 200 tickets. So what do we know about tickets? Well, we know there are two kinds. We have child tickets plus all the adult tickets equals 200. All the child tickets plus all the adult tickets equals 200. What do we know about money? Well, we know $6 times each of the child tickets plus $10 times each of the adult tickets equals $1,500. So we have a cost equation, and we have a number of tickets equations. At this point, we can move into solving elimination by multiplying. The easiest number for me to multiply by is 6. So I'm just going straight through. Negative 6, because I need it to be an opposite. Negative 6c, negative 6a, negative 1,200 replaces the 200. Then I can just add the equations together. Negative 6 plus 6 is 0. There's my elimination. Negative 6 plus 10 is 4a. Negative 1,200 plus 1,500 is 300. Now I can divide by 4, and I end up getting A is equal to 75. And if you want to do it slower, you can. That's fine. How many child tickets were sold? Well, adults were 75. How do I know children? I'm going to plug it back into this original equation. So down here I have more space. C plus A equals 200. Well, C plus 75 equals 200. So by subtracting 75, I get C is equal to 125. And that's my first blank, 125. The second question is, assume the number of tickets sold would not change. How much better, or how much would the theater have profited if each ticket cost $10?
Okay, so what we're doing here is we're just going to take the cost of the adult ticket and we're going to multiply it by 200, which is the total number of tickets sold. So we're going to take the adult ticket cost, times it by 200, and you know that when you're multiplying things by 10, you just add the 0. So 10 times 200 is, should have wrote it right there, 2,000. So assume that the number of tickets didn't change. Well, they sold 200, and each ticket cost $10, and we get 2,000.
Over the weekend, families rushed to the theater to see the summer blockbuster Sharks 2. All tickets were sold at the box office. Child tickets cost $3 each, and adult tickets cost $5 each. The total revenue collected was $3,000, and 800 tickets were sold. The question is asking how many child tickets were sold. This is very familiar. We can begin to identify our unknowns. Well, we know $3,000. We know 800 tickets. We know $5 each for an adult. We know $3 each for a child. What do we not know? We don't know number of child tickets. We'll make that C. And we don't know number of adult tickets.
Cool, so I'm going to make two equations. One is going to be the total cost, based on the total cost. And the other one is going to be based on the total tickets. So the first cost equation, well, we don't know how many child tickets were sold, but we know that each child ticket costs $3 times the number of child tickets sold, plus the number of adult tickets, which cost $5 times the number of tickets sold, equals 3,000. And we also know that the children tickets plus the adult tickets equals 800 total tickets. So here are my two equations. We can now use elimination. So we got to multiply to create an opposite. The easiest number to create an opposite of is -3. So we're just going to scalar multiply all of this by -3. And what we get is, I'm going to write it right here, -3c minus 3a equals -2400. I'm going to delete this so that we can now add down. Now we can add down. What we get is these are eliminated, so we're going to solve for a. -3 plus 5 is 2a equals -24 plus 3,000 is 600. So now we can divide by 2. Divide by 2. A equals 300. We know that there were 300 adult tickets sold, so how many child tickets were sold? Plug A back in for the A in the easiest equation, which was C plus 300 equals 800 tickets total, minus 300, minus 300, C equals 500. So that's our first blank, 500 total child tickets.
Assume the number of tickets sold would not change. How much would the theater have profited if each ticket cost $5? Well, we already know total tickets up here, and we know the price, $5. Total tickets times $5 each is going to be $4,000. And I can go ahead and write that down here, $4,000. Okay, on to the next one. Over the weekend, families rushed to the theater to see the summer blockbuster Die Hard. All tickets were sold at the box office. Child tickets cost $7 each. Adult tickets cost $10 each. The total revenue collected was $306, and 36 tickets were sold. So we're looking for our unknowns. We know the total profit, and we know the total tickets. We know the cost for each adult ticket, and we know the cost for each child ticket. What do we not know? We do not know the number of child tickets, and we do not know, which we'll call C, and we do not know the number of adult tickets, which we'll call A. Then, based off of our totals, we can make our equation. $306. How do we get to dollars? Well, we begin with the equation $7 per child ticket, that's multiplication, plus $10 per adult ticket equals $306. And then we have, for our second equation, all the child tickets plus all the adult tickets equals 36 total tickets. I'm going to go ahead and multiply by an inverse. The easiest inverse for me to multiply this entire equation by, is by 10. I know it's not the smaller number, but it's easier for me. So this is -10c, this is -10a, and this is -360. So that changes by multiplying by 10. Then I can go ahead and sum these equations. 7 minus 10 is -3c. 10 minus 10 eliminates. 306 minus 360 is going to be equal to -54. I can divide by -3. And C is going to equal 18. Negative divided by a negative is a positive, so C is 18. That makes sense that we have 18 tickets. How many child tickets? 18. Assume the number of tickets sold will not change. How much would the theater have profited if each ticket cost $10? Well, total number of tickets times the price, 36 times 10, $360 is what they would have made.